Alright, well today we're going to talk about reducing fractions. Last time we talked about how decimals and fractions are the same thing, and we looked at that. Today we're going to see that fractions can be written the same way, a bunch of different ways. And what does that mean, and how do we reduce them down to be what we call simplest form? So let's get started. What does it mean to reduce fractions? Well, let's look at these two different fractions, and we're actually going to see that they're the exact same thing, except that 1/2 is 4/8 reduced. Now, if you remember, the bottom part of our fraction, the denominator, it breaks up this bar over here, and it breaks it up into that many number of pieces. 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. The numerator, that top number, tells me how many of those pieces I shade in. So we shade 4 of them in. The bottom one works the same way. I need 2 different pieces. This bar breaks it up into 2 different pieces. 1, 2. And the top number tells me how many I need to shade in. I just need to shade in 1. Now we're going to look at it, and we're going to see it's the same thing. So if I actually overlap those two, you can see they are actually exactly the same. And that's what reducing fractions mean. It means that I can take this number right here, and I can reduce it to be this number. So let's take a look at it. How do we reduce fractions? Well, first thing we need to do is we need to divide them up into each number into its factors. We need to find the factors of the numerator and the denominator. So what are factors? Well, factors are the numbers that can be multiplied to create the given number. So if I want the factors of 4, alright? Well, I know 1 and 4 can be a factor, and because 1 times 4 is equal to 4. 2 is another factor because 2 times 2 is equal to 4. Let's look at 8. What are the factors of 8? Well, 1 times 8 is equal to 8, and 2 times 4 is equal to 8. So they're whole numbers, integers, that can be multiplied together to be given that number. Those are factors. So what we want to do is we want to find factors that they have in common. So we can see here that 2 they both have. So what I can do is I can divide both of these numbers by that common factor. I can divide 4 by 2, and I can divide 8 by 2. And you can see 4 divided by 2 is equal to 2, and 8 divided by 2 is equal to 4. So we're ended up with 2 over 4. Now I can divide these factors up again and go 2 and 4. Well, the factors of 2 is 1 and 2, and the factors of 4 are 1, 2, and 4. Well, they have another common factor here of 2, so I can divide them each by 2. Divide by 2. And that gives me 2 divided by 2 is 1, 4 divided by 2 is 2. So I get 1/2, exactly like you saw earlier in the slide before. So we can find what factors they have in common, and then we can divide both of those numbers by that number. One thing that can help us is prime factorization. Prime factorization breaks up the number into all its factors, but all the factors are prime. So how many prime numbers are multiplied together to get it? What we oftentimes use is here we go. The definition of prime factorization: the act of breaking up a number into all of its prime numbers. We oftentimes use a factor tree. You've also maybe used the loopy L method, but I'm going to show you the factor tree here, and then I'll go back and show you the loopy L method. The factor tree, you can just start breaking them up into factors. And when you're done, you're going to circle your prime numbers. So 24. Well, 24 is a result of 4 times 6. Now 4 and 6 are not prime. They can both be multiplied out. And so what's 4? Well, 4 is 2 times 2. Is 2 prime? It is. So I'm done with those. So those I can circle. 6, I can go 2 times 3. 2 is prime, and 3 is also prime. Remember, a prime number is a number that can be multiplied by 1 in itself, and that's it. Those are the only factors of the number. So my prime factorization would be 2 times 2 times 2 times 3. If you wanted to use the loopy L method, remember we do like an upside down division. And numbers we divide by when we do the loopy L method would be 2, 3, 5, 7, maybe 11. Alright, these are the prime numbers, your lowest prime numbers. These are going to be numbers that you want to memorize. And we just start with the lowest number. If my number is even, it means I can divide it by 2. 24 is even, so I can divide it by 2. That gives me 12. I divide that number. It's also even, so I can divide it by 2, and that gives me 6. That's also even, so I can divide by 2, and that gives me 3. And 3 is prime. 3 is in this list of numbers. And so I can create my loopy L. We always go from least to greatest. So we check, does it divide by 2, does it divide by 3, does it divide by 5? Alright. And we can see that it's 2 times 2 times 2 times 3. Exactly what we had with the factor tree. So how can prime factorization help us out? Well, let's look at the factors, the prime factors for each of these. 3 and 6. Well, 3 is just made up of 1 and 3. Both of those, 1's not prime, but 3 is, and so we're good there. 6 is 2 and 3. 2 is prime, and 3 is prime. So 3 has the factors, prime factors of 1 times 3. 6 has the factors of 2 times 3. The number they have in common is 3, which means I can divide them both by 3. So it breaks it up easily to see which number I can divide it by. 3 divided by 3 is 1. 6 divided by 3 is 2. So 3 over 6 is equal to 1 over 2. We've reduced that, or even simplified it. Let's look at another problem. 12 and 36. So let's use a loopy L method for this. 12. That's even. Remember the numbers we're going to divide by are 2, 3, 5, 7, 11. Those are the prime numbers. It's even, so I can divide by 2. That gives me 6. That's even. I can divide by 2. And that gives me 3. 3 is prime, so I'm done. 36. I can divide by 2, and I get 18. I can divide by 2, and I get 9. I can divide by 3, and I get 3. They have to equal out to be whole numbers. So 12, the factors of 12 are 2, 2, and 3. The factors of 36 are 2, 2, 3, and 3. Well, in this case, you can see I have a 2 in common, I have another 2 in common, and I have a 3 in common, which means I can go 12 over 36, divide that by 2, and I've got this one, and that gives me 6 over 18. I can divide it by 2 again, that gives me these common numbers, and that gives me 3 over 9, and I can divide it by 3, that gives me these common numbers, and that gives me 1 over 3. So 12 over 36 is equal to 1 over 3. That's how that works. So especially when we have the larger numbers, you can see which numbers I need to multiply. So I don't have to find the factors again of 6 and 18, and the factors again of 3 and 9. I can just use what I have in common here to divide that by those numbers. Well, that's all I got. If you have any questions, feel free to ask me when you get to class tomorrow. Have a great evening.